Welcome to another edition of the Smart Science series. The topic for today is force and pressure. At the end of the lesson, you should be able to achieve the following study objectives. 1. You should be able to define force and enumerate the different types of force. 2. You should also be able to define pressure and explain its effects in fluids. Then again, you should be able to explain some applications of force and pressure in liquids. Then you should also be able to demonstrate that pressure acts equally in all directions and that pressure increases with depth in liquid or fluids for that matter. And finally, you should be able to explain surface tension and its application. Now, the introduction to the topic before we continue. We make use of forces and pressure in a great deal of activities in our daily lives. We also experience the effects of forces and pressure in almost all our daily activities. In this lesson, we will learn about what force and pressure are, their types and applications, their effects and ways of overcoming their negative effects. Now we come to the definition and SI unit of force. Force is defined as a push or a pull on an object. It changes or tends to change the state of rest or of uniform motion of an object. If an object is at rest, the force will tend to change that state of rest. Or if the body is already in motion or it is moving, then a force on the body will tend to change that state of motion or cause it to come to rest or stop. So that's what we mean by this statement. It changes or tends to change the state of rest or of uniform motion of an object. Then force is also measured in newtons with a symbol N, that is a capital N of course. Thus, its SI unit is newtons, and that is N. So it is measured in newtons, and that is the SI unit for the measurement of force. Now we have so many forms of forces, and these forces are grouped into two main categories or two main classes. The first is what we call contact forces. And contact forces, that is when the source of force is in direct contact with the object on which the force is applied. That is, it may push or pull that object, but it must be noted that for contact forces, the force which is applied to the object must be in direct contact with the object on which the force is being exerted. Then that type of force will be called a contact force. These are examples of contact forces. 1. Frictional force, and that is the force that exists between two surfaces in contact. Frictional force, the force that exists between two surfaces in contact, and so it is obviously an example of a contact force. Then we also have what we call tensional force, and that is the force built up in a stretched rope or rubber band. The force built up in a stretched rope or rubber band, that is a tensional force, and that is also a contact force, an example of a contact force, because the force which is stretching the rope or rubber band is in contact with the rubber band or rope in this case. So then tensional force is a contact force. We also have viscosity as an example of contact forces. And then viscosity is the opposing force in liquids. The opposing force in liquids. We can say viscosity is frictional force in liquids. So that is also an example of a contact force. Now the second class or category of forces is the non-contact forces. That is when the source of force is not in direct contact with the object it pushes or pulls. So in this case, the force may be pushing or pulling an object although, but it is not in direct contact with the object on which it acts. Let's now have a look at some examples. We have gravitational force, which pulls objects downwards, or force of gravity. Then we also have magnetic force. That is the force possessed by magnets. It can either be an attractive force or a repulsive force. We also have electrostatic force, and that is the force exerted by stationary electric charges. Then we also have centripetal force, which is the force that moves object in the circular path toward the center of the circle. Then we also have centrifugal force, which is the force that keeps object in the circular path away from the center. So these are the two forces that has to do with object moving in a circular path: centripetal force and centrifugal force. But centripetal keeps the object towards the center of the circle, whereas the centrifugal keeps the object away from the center of the circle. We now look at some applications of these forces mentioned earlier. So the table presents the forces and their applications, with the force on the left hand side and their applications on the right hand side. So the first on the table is frictional force, and it has the following applications. 1. Frictional force helps cars to move and to stop when the brakes are applied. Then secondly, frictional force helps humans and animals to walk. Then it also helps farmers to sharpen their cutlasses and other tools that will need to be sharpened. So these are some few common and popular applications of frictional force. Then we come to tensional force, and then it also has the following applications. 1. It helps in making instruments like the guitar and the violin. Of course, we have some strings on the guitar, and they are pressed and vibrated to produce the sound or melody. So tensional force is that force which is built in the strings. Of course, it is that force which is made use of in this instrument, that is the guitar and the violin. Then the second application of tensional force is that yarns are stretched when weaving cloth. For example, in the making of kente, the yarns will have to be stretched for them to possess tensional force before they can be correctly woven into nice designs of clothing. So these are also two spectacular applications of tensional force. Then we come to electrostatic force, and then it is also used in photocopying machines. That is, it is a force that is made use of in the photocopying machine. Then we come to magnetic force, and then it has the following applications. It is applied in the manufacture of loudspeakers. So if you are observant enough, you would realize that every speaker has a magnet at the base of it. without a magnet, the speaker will not function as a speaker. So magnetic force is applied in the manufacture of loud speakers. Even in microphones and other instruments, magnetic force is applied. Then secondly, it is used as a method of separation of magnetic materials from non-magnetic materials. Under mixtures and then compounds, we made mention of the fact that magnetism or magnetization is used as a method of separation of mixtures. Then thirdly, most fridges use magnets to keep their doors shut so that they don't allow air, warm air from the outside to enter into the refrigerator. Most of the fridges make use of magnets to always keep the door shut and airtight. So these are also the applications of magnetic force. Then we come to gravitational force or force of gravity. Here we say it helps us to walk freely on earth. That means when you move or lift up your legs, you can put it down or press it down. Now when you go to space and you throw an object into the skies, it will not fall back to the ground because there is no force of gravity to push it down. So then, even if you walk and you lift up one leg and you don't make sure it is down and then you lift the other, you'll be suspended in the air and then you cannot walk effectively. So then we say gravitational force or force of gravity for that matter helps us to walk freely on earth. Then secondly, it brings raindrops down when it is raining. It is the force of gravity or gravitational force that brings the raindrops down from far above in the skies. Otherwise, the raindrops will forever suspend and never come down. But the force of gravity pulls them towards the ground, and so they fall to the ground. So these are also the two important applications of force of gravity or gravitational force. The next force is centrifugal force, and it is used in separating mixtures, just like it is applied in the use of the centrifuge. And the centrifuge is an instrument which moves around in the circular part. So when the mixture is put in that instrument and it is pressed on, it moves very fast so that those components which are a little weighty or that has weight settles to the bottom of the container, and then those that are very light suspend at the top, and then it facilitates the separation of the mixture. So that is one main use of centrifugal force. Then centripetal force is also a force that makes it possible for cars to move round a roundabout. It is that force which keeps the cars in a circular motion as they move around the roundabout. So that is an application of centripetal force. So we now have a look at some negative effects of some of the forces. The first force that has negative effects is frictional force, and these are the negative effects it has. 1. It causes the sole of our shoes to wear out. Though frictional force helps us to walk, as we walk, the contact of our shoes, that is the sole of the shoe, to the ground causes the soles of the shoe to wear out, and this is a negative effect of friction. So that as we walk, by and by the soles of the shoes wear out and we need to buy new ones. So it is a negative effect. Then again, friction also causes unnecessary heating and wearing out of machine parts. That is, those parts that turn around, particularly in engines. As they turn around, because the two surfaces are in contact, they wear each other away. Now this unnecessary heating and wearing out of revolving machine parts can be reduced when it is not necessary by using smooth surfaces and lubricants. So this is an effect, and this is how the negative effect can be reduced. Then we also have electrostatic force and its negative effects. It causes lightning which can damage buildings. Now the lightning and thunder that is observed during raining is caused by electrostatic force, and the negative effect is that it can damage buildings. So in order to avoid damage of buildings caused by this electrostatic force, lightning conductors are fitted to a tall building to take lightning down to the ground so that it is neutralized and it doesn't cause damage to the building. This is mostly observed on high story buildings. Then we come to pressure. Pressure is defined as force per unit area. That means the force acting perpendicularly on a unit area is what is defined as pressure. Mathematically, it is given by the formula pressure equals force over area. So the force acting over a particular area is what we call pressure. So dividing the force by the area will give you the particular pressure acting on that area of an object. The SI unit of pressure is Pascal, and the symbol is PA, or Newton per meter squared. Now the Newton per meter squared is telling us that you have the force which is in newtons being divided by the area which is in meter squared. Now it must be noted that large force produces large pressure, but large area produces small pressure. That means force is directly proportional to pressure, but area is inversely proportional to pressure. Then we now discuss resistance and pressure in liquid. That is resistance and pressure in liquids or fluids in general. Now fluids can be liquid or gas. So the resistance in liquids and gases is what we term as resistance in fluids. Now liquids and gases are referred to as fluids because they can flow. The liquids and gases exert forces, and when that force acts over an area, they exert pressure over that area. So as the air blows against an area, it exerts force against that area, and that force over that area is what we term as pressure. The same way, when a liquid is poured onto a surface, it exerts a force onto that surface, and that force per the area of that surface gives us the pressure of the liquid on that surface. Forces exerted by gases or air and liquid or water oppose the movement of objects through them and are called air resistance and water resistance respectively. Let me take that statement again. The force exerted by a gas, example air, or a liquid, example water, will oppose any object moving in the air or the water. And this opposition of objects by the force the gas or water exert is what we call air resistance in the case of air, or water resistance in the case of water. Now air pressure is the force exerted by air per unit area, and it is commonly called atmospheric pressure. So you might have heard of atmospheric pressure in the report of weather forecasters, that is to see air pressure, and the two are used interchangeably. You can either say air pressure or atmospheric pressure. Liquid pressure is also the force exerted by liquid per unit area, and that is what I explained earlier by saying when the liquid is poured against a surface, it exerts a force on that surface, and the force per area of that surface will give you the pressure of that liquid on that particular surface. The pressure in liquids at a given depth is the same in all directions, and very soon we'll see a diagrammatic explanation or illustration to this effect. The pressure in liquids at a given depth is the same in all directions. Now, liquid pressure increases with depth, so the liquid will exert force which exert a pressure, but the pressure it will exert at the surface of the liquid will be smaller than that which it will exert at the mid portion of the liquid, and that will also be smaller than the pressure which the water will exert at the bottom of that liquid. So as you move down the depth of a liquid, the pressure increases. So then we see liquid pressure increases with depth. Now we have a look at an experiment to show that pressure in liquids increases with depth of the liquid. Now you can make this experiment yourself and observe it by making small holes on the side of a container. Now the holes must be in a vertical order, one on top, one in the middle, and one at the bottom of the container, all in a straight line on one side of the container. The second step in this experiment is that you quickly fill the container with water to the brim, and then you observe. That is to explain that the pressure exerted by the water at the top of the container is smaller, so it forces the water only a little away from the container, but that at the middle portion of the container is much greater, so then it forces the water to a much greater distance from the container, and then that at the bottom also, because the pressure is very high, it pushes the water very far away from the container before it falls to the ground. So this is an experiment to show that indeed pressure in the liquid increases with the depth. Now this is an illustration. Now the box here is what we describe as the container, and you have the holes punched on one side of the container in a straight line in a vertical order, one on top, one at the middle, and then one downwards. Then you place this container on a table and then fill it quickly with water so that you observe the water as they flow through the holes. You could see that the water from the top hole will fall to the ground very short distance away from the container. Then that from the middle hole will move a little away from the container before it falls to the ground. Then that from the bottom hole will move very far away from the container before it falls. And this tells you that the pressure at the top is smaller than that at the middle, and that at the middle is also smaller than that at the bottom of the container. So it is indeed correct to say that the pressure in liquid will increase with the depth of the liquid. Now let's find out some evidences of air or atmospheric pressure. Some evidences of air or atmospheric pressure. Now the first evidence of air pressure or atmospheric pressure is an experiment called the crashing or the collapsing can experiment. And in this experiment, these are the steps that are followed to do the experiment and the observations made out of it. you first pour some water into a thin metal can with a tight lid, for example a can Coke or any can mineral, and then you fill it with the water to about a quarter full, that is 1/4 of the total volume of the container. Then you heat the water while the container is opened until it boils vigorously, and then you take the container with the water in it off the fire and close it tightly. Thereafter, you pour chilled or cold water over the can and observe what happens a few minutes after. And then if you carefully do this and you do it right, the can will crash and then collapse as if it was beaten with wood or metal rod. Then again, another experiment to prove that atmospheric pressure or air pressure is indeed real is when a glass or a plastic cup is filled with water to the brim and a piece of cardboard is held firmly against the rim of the cup and then turned upside down with the hand supporting the cardboard. Then the cardboard remains after the hand is carefully removed, and then by this we see that the cardboard is held in place by air pressure. So after the hand is carefully removed, the cardboard remains in place while the water is still in the container but turned upside down, and this is by the effect of air pressure. So it is the air pressure that holds the cardboard and then prevents the water from pouring out of the cup that was used in the experiment. Now this is an illustration of the crashing can experiment. You have an electric stove and then a can Coke or a can Pepsi container with water, let's say half filled in it, put on the burner. After heating for a while and then the water starting to boil, you take the container away from the heating element and then you cover it tightly so that the vapor will no longer escape. Then you pour chilled water all over the container to cool the container. That's the second step. As you can see, you set it aside on the table and then you observe it some few minutes after. This will be the state of the can after a few minutes. You see that the can will be crushed as if it was beaten with wood or metal rod. This is to tell you that it is the atmosphere that has exerted the pressure on it so much so that the thing is now collapsing at the effect of the atmospheric pressure. So this is indeed a real experiment and you can perform it at home. Then we come to application of air and liquid pressure. The pressure that is exerted by air and liquid are applied in syringes, that is the instrument used to give injections at the hospitals. The syringes for injection are filled with atmospheric pressure. When you draw the piston backwards, the pressure of the atmosphere on the liquid pushes the liquid into the syringe. So that is an application of air pressure. Then secondly, drinking with a straw is by atmospheric pressure. Now when you put a straw in a drink and you suck with your mouth, the pressure of the atmosphere acts on the liquid in the bottle so that it pushes the liquid into your mouth and then you can drink the liquid or the drink in the bottle. Then again, pumps used to lift water from boreholes function because of atmospheric pressure. So these are all applications of atmospheric pressure. Then siphoning also makes use of atmospheric pressure. Now these are all applications of air pressure. When we come to pressure in liquids, we say that it is used in car brakes, which is called the hydraulic system, and this is used in tipper trucks and other hydraulic car jacks to lift them when they are tipping off the sand or stones. Then the brakes also makes use of what we call brake fluid, so that when you push the pedal against the fluid exerts pressure on the brake and then the car can stop. So these are the applications of air pressure and then pressure in liquid. Then we come to the last aspect of this study, which is surface tension. Now, surface tension is the property of water or any other liquid that makes its surface behave as if it is a stretched elastic skin. Most of the time, you can observe ants and other insects walking on the surface of particularly water or other liquids without sinking. It is because of a property of that liquid or water that makes its surface behave as if it is a stretched elastic skin. And this property of the liquid is what we call surface tension. Different liquids have different surface tensions, and then the surface tension differ from one liquid to another. Surface tension of water will be different from the surface tension of kerosene or gas oil or diesel or any other. So different liquids have different surface tension, and the surface tension will determine the weight of an object that can be supported by the surface of that liquid. Now, surface tension is made use of in the manufacture of umbrellas and canopies. So when you stretch the material of an umbrella so tightly, water will fall on the outside of it, but because of the surface tension as a property, the water doesn't penetrate into the fiber of the umbrella, so the water quickly runs off the surface and then falls to the sides of the umbrella. The same is applied in canopies. So canopies, although they have tiny holes in them, they don't allow the seepage or penetration of water because of the property we call surface tension. And on that note, we've come to the end of the lesson 234, and that discusses the topic force and pressure. As the tradition has been, we would have a review of the lesson by looking at some highlights or keynotes to keep in mind. We said a force is a pull or push on an object, and then it is measured in newtons. We also said forces are grouped into two, that is contact forces and non-contact forces. Then again we said fluids, that is liquids and gases, also exert forces. We also said frictional force helps us to walk and also helps cars to move and to stop. Sometimes it produces unnecessary heating and wearing out, so it is reduced by using smooth surfaces or lubricants. Then under pressure, we said pressure is the force per unit area and it is measured in pascals. Then objects that move in air and water are made streamlined to reduce the air pressure or the water pressure that is posed by the liquid or the air in question. Then we also said atmospheric pressure makes it possible to fill syringes for injection, and they also make it possible to drink with a straw. We can also make use of atmospheric pressure by using siphons. We also said pressure in liquids are applied in car brakes so that the car can stop, and then it is also applied in the tipper truck jacks so that they can tip off the sand or stones in them onto the ground. Then we said again that surface tension is a property of water or any other liquid that makes its surface behave as if it is a stretched elastic skin. And we said the surface tension of every liquid vary from any other liquid, and this surface tension is applied in the manufacture of umbrellas and canopies. So that is the end of the lesson, and it's been interesting so far. It's been a while now, but I think we are after academic excellence. So stay glued to your books, and then you can learn about all this that we've discussed so far. Have a nice day, and we'll meet again.